I'm looking forward to your talk. Take it away.
Thank you. Thank you, Jens, for having me. Welcome to the audience. I already chatted with some of you in the mingling area of the networking, and when Jens asked me to give a brief talk, I thought about several topics, and I came up with the Beyond the Rule of Zero. It's one of my pet areas where I work in. For those who haven't seen or known me, I used to be a professor, but I'm now independent and work from home, consultant and trainer. If you like to have your company get C++ training, especially in the area of safety, you can ask me for a quote. What is the rule of zero? And for those of you, when we prepared for tonight, Jens told me, well, my slides are like a professor slides. They're very full and complete and too much on them. You get a QR code where you can actually download the slide PDF with some additional explanation for some of the slides where I had the time to actually provide some more notes explaining stuff that are not self-explaining. So if you are able to pick the QR code, you can find them. Otherwise, you can navigate my GitHub, and for Talks public repository, I try to collect most of my talks, at least the PDF of the slides. And you also have seen my coordinates. I'm regular on Twitter, maybe too much, but you can reach out there, and if you don't want, if you want something from me. So what is my philosophy? That is something I more or less borrowed from Kevin Henney, a good friend of mine. Less code is more software. So if you write a lot of code, it might not be the case that this code is actually easily to understand. So my goal is always to say the same thing with the least amount of understandably code. That doesn't mean to have just one-letter identifiers, but to not have, let's say, elaborate things that the compiler would do for you anyway. And this is part of what this talk tonight is about. So if we, and rule of zero, it's all about you design a class type, and then you have to figure out what special member functions do you have to provide, especially do you need a destructor, what kind of copy and move operations should you supply, and the rule of zero more or less says don't. If you look at the options that you have a 5 special member function in that area: the destructor, the copy constructor, the copy assignment operator, the move constructor, and the move assignment operator. In theory, each of those could be either be public, protected, or private. Gives you 5 times 3 options. And then if you look at the body or the definition of those things, you can either have it defaulted, deleted, or some body actually implemented. You might even have it not even declared, which is actually the good thing to do if you can get away with. And this gives you about 50 options on how to spell those 5 functions. And one of them is actually the rule of zero, if you don't declare any of those. And the other 50 are not all very sane. Some of them are, and this is a talk today. And just consider you can spell copy and move operations also differently, which I don't want to go into right now. Now, some of you might have seen this table. At ACCU 2014, Howard Hinand, the more or less inventor of move operations for C++, actually provided a talk explaining this table. This is about what kind of special member function actually you define, and of the 6 given here, which of those the compiler either provides you or doesn't provide you, or will suppress or enable if you define one of the others. And if you look at this table, there are these reddish part in the middle. If you define a destructor or a copy constructor or a copy assignment operator, you still get the copy operations or the opposite, the other copy operation provided by the compiler, which means this is mostly wrong. If you have one of these things, that is where Scott Meyer's C++03 rule of 3 came from. If you define a destructor or a copy constructor or a copy assignment operator, you should define all 3 of them for your class to make sure that your class behaves sanely. This got more complicated with the introduction of the move operations. Now we have 2 more operations to care about, and also we have some influence on the default constructor, which is either compiler provided or not, depending if you have another constructor defined or not. Now, what can we do? This table, I think I counted 42 entries. Actually, it's 42 plus 1 line. Nevertheless, it's an interesting number, but it's not really helpful. So some people know this table by heart, but I myself might know it by heart, like working with about 3 to 5 years with it and explaining things to others and giving talks about that. But I think this table is not something every C++ programmer can actually consciously apply every day in his or her job. So if you look at the core guidelines, there is a rule of 0 in there. C.20 says, if you can avoid defining a default operations, do. And the reason it's the simplest and gives the cleanest semantics. Simplicity is good. Less code is more software. But actually what it means, the rationale to me is a bit weak. It doesn't really give you all the insights you might need to get to really appreciate the rule of 0. There have been school of thoughts who say, okay, always define all 6 and make them default if they are, and delete them if they aren't, and do something special about. But that is already complicated. That's almost on the level of knowing all of the table I showed you in the previous slide and apply it consciously. So what can we do about the rule of 0? What I say, most of the time, your classes should actually implement the rule of 0. So you make your class in a way that the compiler provided or suppressed default operations just work as you expected. Because even if you define a special number function as equals default or even equals delete, might change the semantics, even if that is exactly what the compiler would do. For example, if you, considering my memorization of the table, if you have a copy assignment operator and copy constructor and define them as equals default because you know the compiler provided versions are actually okay, you make your class a pessimization because the compiler no longer provides you with the move operations. And that can be an issue or it cannot. You don't know, depending on the class sub-object, so its members and base classes. Either it's okay-ish because it would move would copy anyway, or it's not okay. And that is an interesting thing. There is some exceptions for default. One is we see in a moment, and the other one is if you have to define a copy or a move constructor, you might suppress the default constructor and then using equals default to resurrect the default constructor is a good thing to do. So the question is, if I do the rule of 0 always, then there somewhere Scott Myers shouts out, yeah, but there are cases where you shouldn't. Scott Myers' original rule was quite silent about the actual cases when this should happen, when you should care about copy operations and the destructor. And this is where I would like to give more guidance. And most of the time, except with some small print in the edges, you need to deviate from the rule of 0 if your class actually needs to define a destructor. That is the main reason when you deviate from the rule of 0. And the question is, when does your class need to define a destructor? And there are actually 2 major cases, and we will see them in a second. The one most prominent case is you're designing a class hierarchy with virtual member function in the base class, and if you put objects of that hierarchy on the heap and want to delete via base class pointer, you're risking undefined behavior when your base class doesn't have a virtual destructor. So the core guidelines tell us in C35 a base class destructor should be public and virtual. And forget about a small print. I am not sure that's really reasonable and useful most of the time, except for some special cases. And also, the core guidelines tell us, okay, compiler-provided copy operation will slice objects via base class reference. So when you have a class hierarchy, then the default operation is provided by the compiler, and you will get copy. That's the red part in the table we've seen. Then you will actually have the problem that your compiler might take your derived class object that is behind a pointer or reference and silently copy that. So if you have a hierarchy, you only want to have your classes referred to via pointers or reference to base class to actually use the polymorphic behavior. And this means you should suppress the copy and move operations. Now the question is, what is the best way to do so? If you look at the old ways how to do that, we have some old options. We can actually, in C++ 03 and 98, it was common to have private copy operations. So declare them and not use them, and the compiler would not be able to copy your objects because there's no definition, and actually it has no access to the private declared copy operations. The other option would be provide protected copy operations. Still, the compiler wouldn't be able to use them directly, but your derived classes could actually provide copy operations based on those. And the last thing, or the simplest thing without spelling, the easiest to spell out, was to inherit from a non-copyable class, like who's non-copyable, or all your other derived classes that inherit from the base class that is non-copyable will also be non-copyable and prevent further slicing down the hierarchy. In C++ 11, we got new means on how to define things, like we can actually define the copy operations as equal delete, and we have a class that should be non-copyable, and C, we can delete the default, the copy constructor, but that means we have defined a constructor, so our default constructor is gone by that. That means we have to resurrect it, and we can delete the copy assignment operator, and so we actually, to get rid of the copy operations and still have a default constructor, requires us to actually define 3 special member functions out of the 6 possible, considering those that we have. In addition, deleting the copy operation also disables any move operation, which is intended in that case, and I think that was the reason why this was chosen. But again, it's a lot of code, and it's easy to get wrong. What if someone actually changed the delete here to become an equals default accidentally, or typo or whatever? It's really easy to get things wrong and messed up. And it's also hard to review because delete and default are visually very close and really easy to mix up. Or actually, there might be written default and you read delete because you expect it to be equals delete. So the question that I ask myself after seeing Howard's table and some ruminating, maybe several years, is how can we do that in a simpler way, suppress copy operations like for polymorphic base classes? And my answer is yes. It might not be a common one, but I want to make it popular. That's one of the reasons I'm talking right now. So if we look closely at the table, if we define in the lower right corner, if we define a move assignment operator, we get no move constructor, we get suppressed the copy and copy operations. And we keep the default constructor because we haven't defined any constructor. And this means we actually can define a move assignment operator as deleted and get exactly the non-copyability without losing the default constructor. And for a polymorphic base class means we have a destructor defined and still get none of the unwanted operations that we want. And I nicknamed it the rule of Desdemona, and that abbreviation, because it's close to Desdemona, it's okay, destructor defined, you delete the move assignment. Now, if you look at a polymorphic base class, in my book, if that is the case, you always have additional virtual members. There might be special cases where you just want to have the type ID hierarchy and dynamic casting things, but I doubt that this is very common. So you will have some virtual member functions. You define an interface by some virtual member functions, and then you will have a virtual destructor. And because your base class should be kind of abstractish, at least shouldn't have too much infrastructure in it, so that the derived classes actually can have their own variation of the interface, you might want to have your destructor defined as virtual and defaulted. Now, because this is a base class, you want to suppress copy operations, and the rule of Distelmover allows us to make it very simple with just a single additional definition of the deleted move assignment operator, and you still get a default constructor. So your derived classes don't have to hassle around with inheriting, because you might not have a default constructor or have to resurrect the default constructor. And that's the least amount of code to write to get that polymorphic base class. I could give another talk on why not to do polymorphic bases today in modern C++, but there are other people like Sean Parent who have talks on that you can and should follow. Now, the only other means where you have to actually have a destructor defined is when you use RAII, resource acquisition as initialization, or some more modern, we talk about scope-based resource management. That is when you actually find a destructor with the body that does something, that releases a resource that was previously acquired in the constructor. So we need to care about their different situations when you do that. And one warning, if you ever write your own resource management classes and don't just use unique pointer, because your only resource you manage is memory or a file stream object, because you have a file as a resource. If you ever do DIY resource management, never attempt to manage more than one resource in such a class. I tried with the unique resource, which is in the P52 paper of the that was moved into the standard library extension paper, not in the standard. And I can guarantee you it's really error prone. It took several people helping me to make it semi or almost correct. I'm not sure if there are still corner cases not covered by the implementation where there might be leaks or interesting thing happens, especially in the context of exceptions. So it's much better if you have multiple resources to manage, write an RAI wrapper for each of them, and then combine them in a class that is a rule of zero class in the end. Now, if you want to manage a resource, you manage a single resource, as I already said. There are three options how to manage that resource, from simpler to more advanced. The most simple one is a scope manager. This is a managing class that acquires a resource in its constructor and actually releases in the destructor. It might provide operations that operate directly on the resource, or it might provide an accessor for getting a reference to the resource to use later, but usually you will have some actual functionality unless the acquiring and the release of the resource is the only effect you actually want, like, for example, scope lock is providing that in the standard library. To make that actually non-copyable, non-movable, you might already guess, we have the rule of Distelmover to achieve that. The next level, let's say, of the thing is providing a manager that allows to actually give away the resource to another managing object. Like a unique pointer does with the memory, you can only have one unique pointer actually managing a piece of memory, but you can you can transfer the ownership of the resource from one unique pointer to another one, and that is the benefit of the move operations. One of the possible uses of move operation is that transfer of ownership semantics provided by move operations. This should be used for resources that cannot easily be duplicated, but where you actually need that transfer of ownership semantics because, for example, you want to put these things into a container and keep them around. That is when vector, for example, requires you to have a movable type. Otherwise, you cannot put it in a vector easily. And then there's the really expensive thing is the general manager or the manager with the value semantics, where you actually can copy the resource, and the manager type will need to actually provide copy operations that make useful copies of the resource. For example, standard string or standard vector are resource manager types that manage the underlying memory, and they allow the copy, even if it's expensive, the copy operations to, you can copy a vector and get a new vector as a copy, and it's still, let's say it has a value semantics, but it's a new vector, a new object, and a new memory resource for the copied vector. If you go even more advanced, you provide also the move operation for these general manager types. This can be done to achieve an optimization, like the move operations of vector or string, that actually hand over the resource. So do the transfer of ownership in the context of a move operation instead of copying to get the efficiency thing. Now, I provide you with the code schematics on how to implement those. A scope resource manager will keep the resource as its type, as usually as a private member, to avoid, let's say, direct access. It will acquire the resource. The constructor will usually have parameters to actually specify which kind of resource you actually want. The destructor will have a body implementation somewhere that actually releases the resource, and the simplest thing to suppress copying is here, delete the move assignment operator, and then you will get the non-copyability. You still can return those things from a factory function if you like to. For example, if it's a generic type and you have a template parameter that you want to deduce, and it cannot be easily deduced from just the constructor parameters. Also, you might want to use a factory function if you have, let's say, in embedded systems, exception disabled. The only means where, let's say, a constructor can actually signal that the resource acquisition failed is by throwing an exception. If you don't have exceptions, you actually would need a factory function to actually return like an optional of the scope resource to make sure that if the resource acquisition failed, to return an empty optional instead of the actual manager type. If you have that case where you might have a resource manager that is empty, a unique manager might actually be the better choice. A canonical implementation could actually use a standard optional of the resource type to make sure that you have that extra state where it says, oh, I don't hold a resource. This is required if you move from such a unique manager. You actually take the guts, and somehow the unique manager needs to memorize, okay, I'm empty now. I don't have a resource. I'm not managing a resource. My destructor cannot release anything. This is to prevent double releases, which usually might be not the thing you want to. So because we have to define a move constructor, you will actually have to resurrect the default constructor. In the case of optional, will actually create as an empty optional, which is a good, sane thing to actually define your move from state. The standard library tries to wiggle around, and there have been even recent, let's say, even more wiggle way for moved from object state and not relying on anything. But if you define your own class, you better know what your moved from state is for your class, because otherwise you will be very insane. Need to do it. Let's say your code might be not easily understood or sanely used by others. So how do we actually implement the move operation? Well, we actually move the other resource, and in the case of the because we manage it in optional, we have to say that the right-hand side of the move operation is now empty, and the standard optional allows us to reset the optional to make it empty. Assignment is similar. The only thing we have to take care about is prevent self-assignment, because otherwise you might actually assign to oneself, and that would be the same as releasing the resource, which is not something you easily should do that. So if you're not self-assigning, you actually release the own resource and swap out the two resources. The release operation has to check if the optional is actually engaged, and then the actual releasing has to be done, and you disengage the optional. So this comment actually is where the actual resource release is happening. And the destructor as is. If that operation that you have to define here throws an exception or might throw an exception, it's better to actually wrap it in a try-catch block, because you want to make the release operation no except, because it's used in the move operations and the move assignment and the destructor, and you better not throw from those operations, otherwise your code will not behave nicely with the standard library or with other code. Now, the general manager, I cannot give you much more of the information. It heavily depends on what kind of resource you have. If you have memory as a resource, use a unique pointer or a vector or string or a similar container. If you really need to invent your own, take care to mimic their behavior. You might copy the idea from the unique resource to use a standard optional for managing the resource, to have your empty case, especially vector or string don't need that, because they can employ the null pointer or have a length or a pointer field to set to 0 or null pointer to recognize that they are empty. Other types might need more. Here we actually, if you want to implement the optimization with the move operation, that means you actually take the gut stealing. So I sometimes show that with the mailboxes here, where you say, okay, I have a full mailbox on the right-hand side of the move operation and an empty mailbox of the left-hand side. If it's not empty, you will empty it before you move. And then in the end, you will have the left-hand side will contain the actual resource, the letter, and the right-hand side will be empty. That is where actual move happens. If you not define those operations, your class is still movable. It's just that the move operations will be a copy operation. I say expert level coding because copying a resource, especially if it's not just memory, an operating system or some others, you might either not be able to copy, or copying might be much more involved than you would need to. So silently copying might be not worth it. So unique manager might be more the thing that you actually implement yourself. Now, to close up, is the rule of 0 actually rules. Write all your types with the rule of 0 in your mind and very consciously deviate from it only when you define a polymorphic base or a manager class. It's really rare to have the rule of not apply the rule of 0. You might see a lot of examples that don't apply the rule of 0, but most of the examples in let's say in textbooks or otherwise are made up examples or not really complete code, so they might not actually show the actual situations where you would use it. That is one of the pity. C++ is too complex. It's very hard to explain a lot of the details that might be required sometimes to an audience without showing code that is too messy to actually understand. That is a pitfall. That's one of the reasons I try to explain the need for copy and move operations with my manager class concepts. Never ever define a destructor with an empty body. I've seen a lot of code doing that, especially old code. Even the Mars rover code had plenty of classes with an empty destructor with an empty body. That's completely superfluous code. Looks strange. It's not really providing you with something useful, and it clutters your code, especially if someone actually puts something in the pretended to be empty destructor. And it also suppresses the move operations that might optimize your code otherwise freely by the compiler. So never ever define a destructor with an empty body. And the comment doesn't count. So that means you only should define destructors with a non-empty body if you actually know what to do them and if you need to release a resource. And I consider, let's say, a scope logger also be a manager, because you more or less manage some output stream by providing, let's say, an entry and exit of a scope, for example. If you have a virtual destructor, equal default is. It's very rare to have a polymorphic base class that also, in addition, is a managing type. It's best to separate these issues, and it's very rare. I know in the standard library we have, let's say, some stream objects that are polymorphic, but even there, the management actually happens in the derived class and not like the string buff or file buff, and not in one of the base classes. And remember, there are 3 kinds of managers. And even if you don't like ties and don't wear ties, I no longer wear a tie for several years now, unless it's a very special occasion. But nevertheless, managing types are your friend. This is where actually C++ shines, where the destructor makes sense, and with the cleanup, the automatic cleanup, is the killer feature of C++. That is great. And remember, the simplest way to have a non-copyable type is rule of distance mover, or maybe inherit from one. Use my rule of 3 for unique managers, where you define the destructor and the move operations, make them move only, and remember the classic rule of 3 with the copy operations defined for general managers, or 6 where you have all, let's say, copy, move, default constructor, and destructor for general managers. But those cases should be rare and should be written by well-educated people, not on the first day of the first course, C++ course. Just there, stick to the rule of 0. And if you go to your own code tomorrow or tonight or later today, depending on the time zone, look at your code, look at your classes, figure out where you have manager types, where you might still have empty body destructors with empty bodies. Get rid of those, simplify your code, make your code simpler, and get more software out of it. I stop now. There are many things missing, like, for example, how sub-objects like bases or member variables of your type will influence your type's behavior. Even if you stick with the rule of 0, having a, let's say, a non-copyable base class makes your class non-copyable. If you have a unique pointer as a member, your class will be move only. And there are other things that influence your types. Values types that are copyable are usually always good. If you have, for example, empty types can be used for mixing base classes, and they don't do any harm unless you use a reference to them. We have relationship types, and I'm mistyped the list. Sorry for that. With references, pointers, use, spans, and we have non-copyable types and move-only types. I already said that. And what you can read is usually not important. And if you need to reach out for me or still want the slides, you can actually use the QR code. And I'm sure they will be more Q&A and discussion later on. And I'm hoping Jens will chime in and help me how to proceed now. Goodbye.